So hello everyone. Today we're going over 5.1 angle measure. So last time I start talk about the angle measure. I talk about how we can. I start talk about the initial side, also the terminal side. I talk about the vertex of the angle. Also I talk about the angle in the standard position. So the angle in the standard position, if it is the initial side in the positive x-axis and also the vertex it is at the origin point, I mean at 0 0. So today we're going over the quaterminal angle, here quaterminal angle. So I'm going to define the quaterminal angle, any two angle angles in the standard position
In progress.
are quaterminal if their sides coincide. Coincides. So if their sides coincide, what does that mean? I'm going to give example and I will explain what does that mean. So example, find angle that are coterminal with angle theta equal 30. So again, coterminal angle, any two angles in the standard position. What is the meaning of standard position? Like I said before, the standard position mean if the initial side is the positive x-axis and the vertex at the point 0 0. If the both of the angle it's in the standard position, I mean both of them the initial side it is the positive x-axis, it is in the initial side, both of them it is positive, the position is at the positive x-axis and the vertex is at the 0 0, I mean at the origin. So the both of them have the same initial side and the same vertex are coterminal if their side coincide. I mean their sides mean the initial side and the terminal side are coincide. So the question now, find angles that are coterminal with the angle theta equal 30. So to do this, you have first of all graph uh, the Cartesian plane and see where is exactly the angle 30 has a position. So it's in the standard position mean the angle has initial side at the positive x-axis. So here is the positive x-axis. This is the initial side and the terminal side, because the angle is 30, so the terminal side must be in the first quadrant. Why? Because the angle from, so the angle here from this side to this side is 90 degree. We should know this is 90 degree. 90 degree, if you want to convert it to the radian, it is pi over 2. From this point to this point, it is 180 degree, and 180 degree to convert it to the radian, it is pi. From this point, turn around to this point, it is 270 degree, and 270 degree to convert it to the radian equal 3 pi over 2. And from this point, if you want to turn around the x-plane until here, it is 360 degree, and 360 degree equal to pi in radian. So first of all, you should to know the 30 degree, it is less than 90 degree. So it's supposed to be here in this first quadrant. So here is the angle 30 degree. So this is 30. So the question, find a coterminal angles, coterminal with the angle theory. So to find a coterminal with the angle theory, you have to add theory for the 360 to this angle. So the first coterminal angle, number one, is theory plus 360. This is the first coterminal angle. So 360 means you have to turn around starting from this point, from here, turn around the XY plane 360 until this point. So you will see both of the sides, the initial side and the terminal side, are coincide. So the first coterminal angle is by adding 360, and they will get 330 plus 360 is 390. This is the first coterminal angle. Also, if you keep adding 360, you will get a lot of coterminal angle. So 330 plus 360 plus 360 again. What is the answer here? It is 330 plus 360 is 390, and 390 plus 360 is 750. The 750 is another coterminal angle of the angle theory. Here is the second one. Also, the same things if you subtract 360. So 30 minus 360 is again another coterminal angle to the angle theory. So it is minus 330. And the same things, if you keep subtracting 360, you will get another coterminal angle. Is it clear? Is it clear?
Can you explain
So
that
to
one more
find
time?
any coterminal angle, yes, to find a coterminal angle is by adding 360 to the original angle. So the theory, just add 360, you will get the first angle. This angle is a coterminal to the angle theory. And the same things, if you keep adding 360, you will get a lot of angles, and all these angles are coterminal to the angle theory. The same things also if you subtract. If you just keep subtracting 360, you will get a lot of angles, and all these angles are coterminal to the original one, the theory. Is it clear? So if I ask you find the coterminal angle, just you keep adding 360, or you keep subtracting 360 degree.
Professor, I have a question.
Yes.
So would it just basically mean like to make like a circle and then land in the same spot where it was a 30-degree angle before?
Yes. Yes.
Okay.
For how many times here I get question? It depends. If you need like, if the question asks you find a coterminal angle like five angles coterminal to the theory, just you can adding 365 times, or you can subtract or whatever. Just you can find 5 angles, and the 5 angles are coterminal to the original one. Can you hear me? Okay, so the main idea for coterminal angle is by adding or subtracting angles, 360 degree. Okay. My example is find a coterminal angle for the angle theta equal pi over 3. This angle, it's in the standard position. First of all, like I said before, you have to graph the location of this angle to know what is exactly the location. So first of all, you have to know this angle has initial side is the positive x-axis. So here is the positive x-axis. This is the initial side. Now, pi over 3, it is less than pi over 2. The pi over 2, it's the 90 degree. The location for pi over 2 is here, like this. This is pi over 2, pi over 2, or 90 degree. Pi over 3 is less than pi over 2. So the location for pi over 3 is in the first quadrant. Okay, it is here in the first quadrant. So here is the angle pi over 3. Here is pi over 3. Now my question is, find a coterminal to this angle. How can I find a coterminal to this angle? Pi over 3. How can I find a coterminal to this angle? Pi over 3 is 60, exactly, correct. If you want to convert pi over 3, as I teach you last time, it is 60. You have to multiply by 180 over pi. Okay. So how I can find the coterminal angle for this? So like I said before, you can add, just keep adding. You don't have to convert this angle to the degree to find the coterminal. So I will teach you here how you can find a coterminal angle without converting this angle to degree. So actually, if you want to find a coterminal angle, this is mean the initial side is the same and the terminal side are the same. So just by adding 2 pi to this angle, 2 pi means you have to turn around the xy plane like this and you go back to the same place. This is 2 pi. 2 pi is equal 360 degree. If you want to convert the 2 pi to degree, is the same as 360 degree. So the pi over 3, you can find a coterminal by adding 2 pi to this angle. So this is the first 2 pi. What is the answer here? Yes, 180 is equal pi. 2 pi is 360, correct. So when you add 2 pi, this is actually over 1. You have to make the denominator equal. So I have to multiply this by 3, multiply this by 3. Now I will get pi over 3 plus 3 times 2 is 6 pi over 3. So the denominator now equals. So I can adding the numerator. 6 pi plus pi is 7 pi over 3. So this is the first angle. Now the second angle. Just you have to keep adding 2 pi. So 7 pi over 3 plus 2 pi plus 2 pi. What is the answer? So 2 pi plus 2 pi is actually 4 pi. So this is equal pi over 3 plus 4 pi. Now you can make the denominator equal. So this is actually over 1. You have to multiply the both sides by what? By 3. Same like before. Now the answer is pi over 3 plus 3 times 4 is 12 pi over what? 3. And this is equal 13 pi over 3. So this angle is a coterminal to this angle, to the pi over 3. It is a coterminal to the original one. And also this angle is a coterminal to this angle. If you subtract the same things, so pi over 3 minus 2 pi, what's the answer? You have to make the denominator equal 1, then you have to multiply both sides by same things by 3. So now you can get pi over 3 minus 6 pi over 3, and this is equal 1 minus 6 is minus 5 over 3. Exactly, minus 5 pi over 3. And this angle again is a coterminal to this angle, the pi over 3. Exactly, Eric. Yes, what's your question?
Okay, so on the exam, if you ask us to find a coterminal, do we have to find 1 or 3? Because you keep going.
You can find, yeah, just you can like find 2. It's fine to find 2.
So is the question gonna
By
say
adding,
2, or is it just gonna say find?
no, if the question would be the question would be like a clear. Find 2 angles
Okay.
are coterminal to the angle is given in your question.
Okay, thank you.
Okay,
Mhm.
it will be like direct and like they will not be confusing. Find two angles are coterminal to the angle, for example, pi over 3. Okay, now another question here for the coterminal. Yeah, so another example, here, the example here will be like similar to the coterminal, but in different word. So the question is, find an angle with measure between 0 and 360 that coterminal with the angle of measure 1 to 90 in standard position. The question here, it is a little bit different about what we said before. Find an angle with measure between 0 and 360 that is coterminal with the angle of the measure 1290 in the standard position. So the main idea here, my angle, my theta, is equal 1290 degree. Now I'm going to find a coterminal angle to this angle such that the coterminal is an angle between 0 and 360. So the best idea for solving a question like that, we have to keep subtract 360 from this angle until we get an angle between 0 and 360. Okay, let me do the first one. So 1290 minus 360. What is the answer? What's the answer? So what's the answer? 1290 minus 360. It's 930 exactly. So the answer is 930. Is the 900 between 0 and 360? Is this angle between 0 and 360? No. So this not belong to the angle between 0 and 360. So this is not my answer for this example. Now I'm going to keep subtracting 360 from this angle. So I get here 930 minus 360. So actually, again, this angle here, this angle, and this angle are coterminal. But this angle is not the answer for this example. Again, 930 and 1290 are coterminal angles. Both of them have the same sides. Both of them have the initial sides and the terminal side. But 930 is not the answer for this example. The example looking for an angle between 0 and 360. So let me keep subtracting again. 360, what the answer I will get?
It will be 570.
570, exactly. So 5 here, 70. Now 570 is a coterminal angle to the 930 and also for 1290. But is this angle between 0 and 360? Is this angle between 0 and 360? No.
No.
So this is not my answer to this question. So I have to keep subtracting again. 570 minus 360. What's the answer?
210.
210. This angle again is a coterminal to 1290 and coterminal for 570 and coterminal to the 930. Is this angle between 0 and 360?
Yeah.
Yes, exactly. So the answer is yes. So this is my answer for this example. So the answer is 210. So the question is find an angle measured between 0 and 360 that coterminal with the angle 1290 is 210. So the coterminal angle is 210 degree. Okay, any question? Okay, so now we're going to the length of circular arc. The length of the circular arc of a circular arc. So I'm going to give you a formula for how we can find the length of the circular arc. So suppose I have a circle like this. This circle has a radius, has a center first of all. This is my center and it has a radius r. This is the radius. And also they have an angle theta. This is theta. This is r. And the distance from this point to this point is called the length of the circular arc. I'm going to denote it by S. So here we have a formula for S by using the radius and using the theta. So S equal R times theta. Theta here must be in radian. Must be in radian. Must be in radian. So we cannot measure the length by using the degree. So S equal R times theta. Also, we should to know another formula is called the area of the circular arc or the circular section. So suppose I have a circle like this, again, same like before. And this circle has a radius r. And I need to find the area of this section. I need to find the area of this section. So it's look like a bite of pizza. So we have a formula to find the area of this section. If I have the radius r, and the same things I have theta, I have the value of theta. So the area A equal, the formula said A equal 1/2 times r square times theta. And theta here must be in radian again. Must be in radian. If it's not in radian, we cannot do the calculation. Okay? So now we have two formulas. First formula is S equal R times theta to find the length of the section or the circular arc, and to find the circular section, the area, by using the formula 1/2 times R squared times theta. Would always be our angle, right? What's your question, Dilian? Theta. Yes, theta is my angle. Yes, it is my angle. But the angle here must be in radian. Okay? The angle here must be in radian. You have to convert it to the radian to find the calculation for the example or for the question. So I'm going to give example. Example now. Find the circular arc and the area of the section for circle has radius 10 and angle 30 degree. Now, what is the area? What's who will remind me what is the formula for the circular arc? So what's the formula for the circular arc? Here's my angle again. The radius is 10. So here is the radius. And the angle is 30. Suppose this is 30 degree. The radius is 10. R times theta, correct. If you want to find the length of the circular arc, R times theta. Theta here must be in radian, right? So theta equal 30 degree. How I can convert it? So it must be in radian. So first step, I have to convert the radian, the theta. Yes, exactly. So the theta, we have to multiply by what? By over 180. So 30 divided by 180, I will get what? Pi over 6, pi over 6. So this is the first step, converting the degree to the radian. So the 30 degree, it's pi over 6 radian. Step number 2. Find the length of the circular arc. Find the length of the circular arc. So I should use this formula. S equal R times theta. And this is equal, R is pi over 6. I mean, R is 10. So R is 10. So this is equal 10 times pi. Pi is pi over 6. What's the answer? Is 10 pi over 6. I can simplify. What is the simplifier for this? What's the simplifying things for 10 pi over 6?
Can you say 5 pi over 3?
Yes, exactly. 5 pi over 3. So the answer here is equal 5 pi over 3. Now, we need to find the area. What's the area? Circular section. What's the area of the circular section? The area formula equal 1/2 times what? Times r square times theta. A equal 1/2 times r square times theta. Now, what is the radius? Is again 10. What is theta? Must be in radian, pi over 6. So this is equal 1/2 times r square is 10 square times theta. Theta is pi over 6. And the answer is, here we have 100. 100 over 2 is 50. 50 over 6 pi. We can simplify this again. What's the answer?
25 pi over 3.
Yes, exactly. This is equal 25 pi over 3. This is the answer for the area. Okay. So this is what you should to know about this section. Now let's go to the second section in this chapter, 5.2. Any question before we leave? Can you explain one? Number one, this one. This one, Eric. Here we have to convert the degree to the radian. To convert the degree to radian, we have to multiply the angle by pi over 180. This is the formula we used last time. To convert the degree to radian, we have to multiply the degree by pi over 180. So 30 times pi over 180, we can simplify the 30 with 180. So here the 30, we can simplify it with 180. So this one will be 1, and 180 will be 6. Yes, if you want to convert to radian, you have to multiply by 1 over 180. If you want to convert to degree, you have to multiply by 180 over pi. Clear? Okay. Another question? Anyone has a question? Okay. 5.2, trigonometric of right triangle. Trigonometry of right triangle. Trigonometry of right triangle. This section is easy and nice in the same time. It's not much hard. So here in this section, we're going to start talk about the trigonometric ratios. Trigonometric ratios. So suppose I have a triangle. This triangle look like this. This is not any triangle, it is a right triangle. I mean, for right triangle, what is the meaning of right triangle? Any idea? What's the meaning of right triangle here? Any idea? Right triangle. This means I have a triangle, and one of the angles has a right degree. Right angle means they have an angle has measure 90 degree exactly. Again, right triangle means we have a triangle such that one of its angles has 90 degree. 90 degree. This is the meaning of right triangle. Again, right triangle, it is an triangle such that one of his angles has 90 degree. So this is 90 degree. So trigonometric ratios will be defined by using the right triangle. Suppose this angle, it is theta. The side that is in front of theta called the opposite side. So this is the opposite. This side called the opposite side. This side called the opposite. Clear? Here, opposite. And this side from this point again, this side from this point to this point is called the opposite side of the angle. And this side starting from this point to this point called adjacent side. Again called the adjacent side. So this side is the adjacent side here. And this side from this point to this point, I mean this side here, let me color it by the blue. This side here, called the hypotenuse. I'm sure you see these names in high school or before, right? And maybe you forget the names. So I'm going to remind you this names. Again, suppose I have a right triangle. It is a triangle has a 90 degree. In front of and I have an angle, acute angle. This my acute angle. The side that's in front of this acute angle called the opposite, and this side behind or below of this angle called the adjacent, and this side, the blue one, called the hypotenuse, side. So now I can define the ratio, the trigonometric ratios. So first one is called the sine function or the sine ratio. I still did not say function because I'm in the ratio. The sine ratio of the angle theta is the opposite over the hypotenuse. This is correct. Opposite over hypotenuse. Okay. The cosine function equal the adjacent over the hypotenuse. Adjacent over the hypotenuse. The tan ratio, the tan theta equal the opposite over the adjacent. Over adjacent. In the same things, we have a reciprocal of the tan, of the sine. The reciprocal of the sine called cosecant. Cosecant theta is equal 1 over sine theta. And this is equal the hypotenuse over the opposite. Now the reciprocal of the cosine function. The reciprocal of the cosine called secant function. Secant ratio theta. This is equal 1 over cosine of theta, and this is equal the hypotenuse over the adjacent. And the tan has a reciprocal is cotan of angle theta. This is equal 1 over tan of theta, and this is equal adjacent over opposite. Any question? So all of them you have to memorize. You have to know what's the opposite, what's the adjacent, what's the hypotenuse, how you can find the sine of theta, the cosine of theta, the tan of theta, the secant, the cosecant, and the same things, the cotan. I'm going to give example for this. Here is the example. Find the trigonometric ratio. So my example now, find the trigonometric ratios. Yes, I can go back here. Okay, so my question now, find the trigonometric ratios if the angle, so my angle now here, the theta, if this, I mean like if cosine of theta, the cosine of this theta equal 3/4. So to find the trigonometric ratios, I mean like the sine, the cosine, the tan, the reciprocal of the sine is cosecant and secant and cotan. So the first all, like the first things you have to do, you have to graph, you have to draw a triangle, right triangle like this. You have to graph a right triangle. This is my right triangle. This is my right triangle like this. And you have to label the angle. So the angle here is theta. So the theta should be here. This is my theta. The cosine of theta, the cosine of theta equal 3/4. It's given. What is the formula for cosine of theta? If you go back to the previous slide, cosine of theta equal what? Adjacent over hypotenuse. So the adjacent over hypotenuse. So this is my adjacent, the 3 is 3, and the hypotenuse is 4. So the value from here, this point, to this point is 3, and from this point to this point, the length is 4. Now my question, what is the value here? To find this value, I'm going to name it by x. So here is x. I'm going using the Pythagorean theorem. The Pythagorean theorem said the length of this side, plus, I mean the length of the adjacent square plus the length of the opposite side square equal the hypotenuse, the length of the hypotenuse square. So the hypotenuse, by using Pythagorean theorem, using Pythagorean, something wrong here, Pythagorean. Pythagorean theorem. We should to know x square plus 3 square equal 4 square. Now my goal is to find the value of x. So x square plus 3 square is, what is the 3 square? What is the 9? Exactly, it's 9 equal what? 4 square. What is the 4 square? 16. Now I have to subtract the 9 for both sides. Why? Because my goal is to find the value of, so when I subtract the 9, this cancel out. 16 minus 9 is, so I can get x square equal what? 16 minus 9 is 7. Now you should to take the square root for both sides because I need the value of x. So the value of x equal what? The square root of 7. So the value for x here equal the square root of 7. Now I can find the sine, the cosine, the tan, the cosecant all the functions, all the ratios. So first of all, what is the sine of theta? What's the sine of theta, number one? What's the sine of theta? The formula for sine, it's the opposite over the hypotenuse. What is the value of the opposite? We just find it right now. It's the square root of 7. Square root of 7 over the hypotenuse. What is the hypotenuse? Over 4, correct. So this is the first ratio. Second one, the cosine of theta is given. Cosine of theta is 3 over 4. But let's make sure our solution is right. So it's equal the adjacent. This is my adjacent over the hypotenuse over 4. So this is equal 3 over 4. Number 3. What's the tan? The tan of theta. What's the tan of theta? The tan equal the opposite over adjacent. The opposite exactly here, Dillian. Square root of 7 over what? The 3. Correct. Over 3. Square root of 7 over 3. Now I can find the reciprocal of the sine. The reciprocal function or ratio of the sine is called the cosecant. So number 4, cosecant of theta is the reciprocal of this 4 over square root of 7. Number 5 here, it's the secant, the reciprocal of cosine. We have to flip the cosine. It's called the secant of theta. Take the reciprocal of this 3 over 4 is 4 over 3. Correct. And the last one is the cotan of theta. It is the reciprocal of the tan. Square root of 7 over 3 will be 3 over square root of 7. Any question for this example? Any question for this example? It's easy, but you should to know the Pythagorean theorem and how you can apply for the Pythagorean theorem. Now we have some special values. We have some special values. Here some special values. So what does that mean? So this is me. I'm going to share my screen. One second. Here you go. So this angles is a special angles. These angles are special angles. So this angle here is in degree, and this angle it's in the radian. Clear? Everyone can see the picture? You can see the picture here? So this degree, this column, it is in the degree, and this column, it's in the radian. First of all, we know how we can convert from degree to radian. From degree to radian, we have to multiply by pi over 180. So the 0 degree, it's the same as 0 radian. 30 degree is the same as pi over 6 radian. 45 degree is the same as pi over 4 radian. 60 degree, it's the same as pi over 3 radian. 90 degree is the same as pi over 2 radian. Now, these angles are special. Yes, you have to memorize this. So you have to know the sign of this, the 0 is always 0. The cosine of the 0 is 1. The tan of the 0 is 0. The cosecant of the 0 is undefined. We don't have a value. Why? The cosecant, it is 1 over sine. And the sine is 0. 1 over 0. What is the equal for 1 over 0? 1 over 0 is undefined. We don't have value. That's why here does not have a value. The secant, it is 1 over cosine. And 1 over cosine is 1. 1 over 1. The cotan, it's the same as 1 over 10. 1 over 10 is 0. 1 over 0, it's undefined. That's why we put the dash here. Okay. Now for 30, the sine of 30 is 1/2. And the cosine of 30, it's the square root of 3 over 2. And the tan of 30 is by dividing the sine over the cosine will give me the square root of 3 over 2 over 3. And the same things for the cosecant and the secant and the cotan. All of them are the reciprocal. Now for the second degree, for the 45 degree, we have the sine, it's the square root of 2 over 2. The cosine is square root of 2 over 2. And the tan is dividing the sine over cosine is 1. Again, theta in degree 60 is the square root of 3 over 2. The cosine is 1/2. The tan is square root of 3. The same things for the reciprocals. The 90 degree, the sine you should know it's 1. The cosine is 0. The tan does not have a value. Why? Because the tan is actually equal sine over cosine. 1 over 0, it's undefined. That's why the tan does not have a value. Cosecant, it is the reciprocal of sine, 1 over 1. The secant, it is the reciprocal of this cosine, 1 over 0. Cotan, here look, we doesn't have a value, but the cotan actually equal the cosine over the sine. The cosine is 0 over the sine is 1, so 0 over 1 is 0. So that's mean the cotan has at 90 degree has a value 0. Any question? Anyone has a question? This table, you should to memorize it. You have to know all the values. It's not much hard. So I'm going to leave, going back to the whiteboard. Any question before we go back? Okay. So we'll talk about some special values. Let's talk about the tables. Now, let me give you an application for using the ratios. How we can use the ratios. Okay. So here some application for the ratios. Application of trigonometric of right triangles. Okay. So my example now, solve the triangle ABC. Suppose I have a triangle ABC like this. I'm going to graph it, show in the picture. Here's my triangle. This is the ABC. So this value is A. This value is my B value. Here the head is called B. This is C. And suppose this is the angle is 30 degree. So my question now, show in the picture, find the value of A. This is the small a, and find the value for the small b, the opposite of the vertex. I mean for the angle capital B. And the value from A to B, the length, it's 12. So my question is find the value for small a and small b. Okay, who do the first one, or any idea how we can find the length a, the small a? How we can find the length of a? So the sine function here, or the sine ratio, sine of the angle theory. What's the sine ratio equal? The opposite over what? Hypotenuse.
The hypo.
Okay. Now, what's the value for the opposite? It is a. And the hypotenuse is 12. Now, sine of 30 equal a over 12. I can multiply both sides by 12 to get only the value for a. Or we can do the cross multiply. I mean, for cross multiply, this is actually over what? Over 1. This is actually over 1. So cross multiply like this, I will get a equal 12 times the sine of 30. Now, my question is, what's the sine of 30 by using the table?
1/2.
1 over 2, correct. So A equal 12 times 1 over 2. And what is the value? 12 times 1 over 2?
6.
6. So the value for A is 6. So this is equal 6 unit. Now my question is find the value for B. This B. How can I find the value for B? What function, what ratio I can use for the theory help me to find the value of B?
The cosecant of 30.
Cosecant or the
Yeah,
cosine?
I meant cosine.
Cosine. Yes, the cosine will help me because the cosine of the angle 30 degree equal the adjacent over the hypotenuse. Adjacent edge over hypotenuse. What's the value for the adjacent now?
It's B.
Is D
It's
over
B over 12.
12, correct. Now, to find, we can do the cross multiply. What's the cross multiply? So actually I get cosine of 30 equal B over 12. Do the cross multiply, you will get B equal what?
B equals cosine over 30 times 12. And cosine over
Cosine
30. I meant cosine of 30
of,
is the equivalent to the square root of 3 over 2.
yes, square root of 3 over 2. So the cosine of 30 from the table, it's the square root of 3 over 2, correct. So here I can say B equal the square root of 3 over 2 times 12. Now, if you want to simplify it, the 2 with the 12, how much you get?
It'll be 6 to the square root of 3.
Correct. So it will be 6 square root of 3. So the value for B equal the 6 square root of 3. This is the answer. So I find the value of B and I find the value of A. This is the first application I can use it by using the trigonometry ratios. Any question before we go to the second example? How did you get the cosine from the table? From the table, Eric. You have to memorize the table. The cosine of 30, it is square root of 3 over 2. Okay? Cosine of 30 is the square root of 3 over 2. The sine of 30, it's 1/2. Why it's cosine? Okay. So I use the cosine because I need to find the value of B. So the best ratio to find the value of B is using the cosine because the cosine of the angle equal the adjacent. The adjacent, it's B over the hypotenuse is 12. So if you want to use, for example, the sine equal the opposite. This is the opposite over the hypotenuse. So you can find the value of A. If you want to use the cosine for the angle theory, you can use it's equal the adjacent over the hypotenuse. The adjacent is B over the hypotenuse is 12. So you can find the value of B. That's why here, for the second part, to find the value of B, I use the cosine. Cosine helped me to find the value for B because the cosine equal the adjacent of the angle over the hypotenuse. Adjacent, it is B, the hypotenuse is 12. And then I did the cross multiply and I find the value of b. Is it clear? Clear? Okay. Now, another example for the application of trigonometry of right triangles. Would it have been incorrect to use the Pythagorean theorem to determine b, since we already... No, it's clear. No, it's correct. If you find the value of a and you have the value of the hypotenuse, it's 12, it is easy to use the Pythagorean theorem. You will get the same answer, 6 square root of 3. Patrick, you can use the Pythagorean theorem if you find the value of a by this one, and also you have the hypotenuse is 12. You can use the Pythagorean theorem, this is correct, to find the value of b. You will get the same answer, 6 square root of 3. Okay. It's not necessary to use the cosine. If you would like to use the Pythagorean theorem, it is fine. Will help you to find the answer. Another example, and this example is very important, and you have to like focus on the example like this. I recommend you to focus an example like this in WebAssign or for this example. So I have a tree. This tree makes a shadow 532 feet long. The question is, find the height of the tree if the angle of the elevation of the sun is 30 degrees. So how can I find the length of the tree such that they give me the length of the shadow of the tree, and also they give me the degree, the angle of the elevation from the sun. So I'm going to graph. The graph will help me a lot for finding the value. So here's my tree. This is my tree. I'm going to move it a little bit to the left, like this. Here is the tree. Okay. Also, I have a sun. This is the sun. This is the sun. This sun makes a sun ray like this. Let's make an angle with the tree like this. Okay. So here is the sun. This sun also make a shadow for the tree. Here is the shadow for the tree. The shadow has a length 532. This is the shadow. It is 532 feet. And the angle is 30. So the 30 here, this is 30 degree. My question is, find the value for the length of the tree, x. Find the value of x. What is the best ratio I can use it to find the value of x? what is the best ratio? I mean the sine, cosine, the tan, or the reciprocal of them to find the value of x.
You would use
tan.
tangent.
Tangent, correct. The tangent, tan, of the theory, what is that equal? The opposite over the adjacent. The opposite, it is x. Adjacent. So this is equal x over what? 532. So now it's easy to find the value of x because the tan of theory is given from the table and this is known, but x is unknown. So now it's easy to find the value of x. Do cross multiply. So x equal tan of 30 times 532. What is the value of tan? What's the value of tan?
I think it's square root of 3 over 3.
Exactly, the square root of 3 over 3 times 532. So x equal 532 times the square root of 3 over 3. This is my answer. This is the length of the tree. This is the length of the tree. Any question? Any question for this? This example is very important. Please focus for this example like this. Okay, so the section is finished, 5.2. This is the important things you should to know. Now we're going over 5.3, trigonometric functions of angle. Trigonometric functions of angle. 5.3. Trigonometric functions of angle. So 5.3 trigonometric functions of angles. So in the previous section, 5.2, we were only talking about trigonometric ratios for acute angle. Acute angle, I mean like any angle between 0 and 90 degree, like 30, 40, 45, 60. Any angle between 0 and 90, it is acute angle. So in the previous section, 5.2, we was talking about only the angle, only the acute angles. Today in this section, we're going to talk about trigonometric ratio for any angle between 0, I mean like any angle between 0 and 360 and also maybe greater than 360. So it is not that much hard. We have some steps, easy steps. We're going to follow the steps to find the value for the function for the trigonometric for the function. So first of all, we have to know here step number 1 here. Trigonometric function of angles. This is mean if I have all my angles in this section or also in the previous section, all of them are in the standard position. All of them. I mean in the standard position, the initial side, it is the positive x-axis, and the terminal side, it's anywhere, doesn't matter. But the initial side must be on the positive x-axis, and the vertex must be the origin point, the 0, 0 point. I'm going to graph some angles. These angles will help you a lot during this section. So first of all, we should know how to graph the angle 0. Here is the angle 90 degree. Here is the angle 180. Here is the angle of 270. Let me make a space for the last one in this slide. Also the angle of 360. This is the angle for 360. Okay. So like I said before, all the angles are in the standard position. I mean, in the standard position, the initial side must be in the positive x-axis like this. So this is the first one, the x-axis, initial side here. Here's my initial side. Here's my initial side. Here's my initial side. Now, so the first one is the 0 degree. The 0 degree has looked like this. My initial side, it is in the positive x-axis, and my terminal side is also in the positive x-axis. So this is 0 degree. Here we have 0 degree. And also the 0 degree is the same as the 0 radian. This is equal 0 radian. For the second one is the 90 degree. Here is the 90 degree. This is angle is 90 degree, or pi over 2 radian. So this angle here is pi over 2 radian, or this is equal the same as a 90 degree. For the third one it is 180 degree. So the 180 degree is pi in the radian. So this is angle is 180 degree, and it is pi in radian. Now for this one is 270 degree. So here is the 270. This is 270 degree. And this is 360. Again, this angle is 270. 270 degree equal 3 pi over 2 radian. And here the angle is 360 degree. 360 degree. This is equal 2 pi in radian. This is number 1, number 2, number 3, 4, and 5. Any question? Clear? From 1 to 5? Okay. We have also we have 3 more angles. We have 3 more angles. So we have also the angle 30 and 45 and 60. Here is 30, here is 45, here is the 60. So first of all, like I said before, all of them, they have the same initial side. All of them, they have the same initial side. Yeah, here you go. Have you finished? Okay. So all of them, they have the same initial side. Here's my initial side, the positive x-axis, my initial side, my initial side. And the vertex, it is the origin. Now, the 30-degree should be the angle like this. The 45-degree should be like more a little bit up, like this. And like this. And the 60-degree should be like more up and up. I think like angle like up like this. Okay, for the first one, it is 30-degree. This is the 30-degree. The 30-degree, to convert it to the radian, equal pi over 6 radian. This angle is 45-degree. When you convert it to the radian, it is pi over 4 radian. And this angle is 60-degree. To convert it to the radian, it is pi over what? 3. Pi over 3 in radian. So here we stop at 5. This is number 6. This is number 7. This is number 8. Clear? The angle here?
Sorry, can you go back for a second?
Yes, here.
Thank you.
No problem. Now, I'm going to talk about the trigonometric function of angles for any angle. And like is not acute angle, any angle. But before to do that, I have to graph a right triangle. Then I have to put it in the standard position. Then I have to define the sine, the cosine, and all these functions. So now I can set trigonometric functions of angles or for angle. So I have to define a right triangle like this. First of all, I have to graph the x and the y axis like this. This is my x. This is my x-axis. This is my y-axis. Now I'm going to graph the right triangle like this, and here is this side. Like this. Okay, and also I have this side. Three sides. And I have also another things. My angle is here. My angle. This is my angle. Theta. First of all, the angle here I have a right triangle. They have a name O, Q, and this point here is called P. This is called X. This is called Y, this side, and this is my R. My R, by using the Pythagorean theorem, equal the square root of x square plus y square. Now I can define the sine, the cosine, and all this function. I did not use ratio, I use function. So my sine function equal y over r, such that this r does not equal 0. The cosine function, the cosine of the angle theta, equal x, this x over r. And again, r not equal 0. The tan function, the tan of the theta, equal y over r. Y over r. Again, r not equal 0. So first one, second one, third one. Also the same things for the reciprocal. Here I have sine. The reciprocal of the sine is cosecant. Cosecant of theta is the reciprocal of this, r over y. R over y. The tan is y over x. Yeah, sorry. Okay, y over x here. Y over x, correct. The tan of theta equal y over x, correct. Hey, cosine of theta is the reciprocal. We have the secant. The secant of theta is r over x. The tan, we have the reciprocal is cotan. Cotan theta equal x over y. So here 1, 2, 3. We have also 4, 5, 6. We have 6 functions. All of them called functions. Function sine, function cosecant, the cosine function, the tan function. Now we're going to learn how we can evaluate a trigonometric function at any angle. We're going to learn how we can evaluate a trigonometric function at any value. I'm going to move to the next slide. So here, evaluate trigonometric functions at any angle. So to do that, we need only 2 steps. The steps are very easy. The first step, we need to find the sine of the trigonometric function. The sine of the trigonometric function. The second step is to find the reference angle. So for the first step, I'm going to explain the first step here. Number one. Step number one. How we can find the sign of the trigonometric function. The sign means positive or negative. This is what the meaning of sign. So the sign of trigonometric function. Okay. So the sign of the trigonometric function, the sign number one, this is number one here. What does that mean? So we should to know the trigonometric function has a sign. It depends on the location of the angle. So in the first quadrant, if the angle is in the first quadrant, all the functions are positive. I mean, the sine function has positive answer. The cosine, the tan, the cosecant, the cotan, all of them has a positive answer. For the second quadrant, the only function has positive answer is the sine of the angle. For the third one, it's the tan only. The tan has a positive answer. For the fourth quadrant, only the cosine has a positive answer. Okay, so I can collect all of this in one word. All, the first letter in this word, all student, S, all student, take the T letter here, take. C is a calculus. All student take calculus. Just to help you how you can memorize this table. All student take calculus. All functions, sine, cosine, tan. Student, the sine function only positive. Take is the tan function is the positive only. Calculus, the cosine function, is the only function positive in this quadrant. This is about the sign. Now we're going to talk about the reference. What is the meaning of reference angle? What's the meaning of reference angle? So step number two is the reference angle. Step number two. Here, number two. Reference angle. What's the meaning of reference angle? So the reference angle mean, so here it has a definition, and this definition I'm going to explain what is the meaning of the reference. So the reference angle, let theta, suppose I have an angle is called theta. Let theta be an angle in the standard position. The standard position such that the initial side and the terminal side the initial side must be in the positive x-axis. Okay, let me continue the definition. Let theta be an angle in the standard position. The reference angle is the acute angle. Acute angle is any angle between 0 and 90, formed by the terminal side of angle of theta and the x-axis. So I mean, for this, I'm going to explain this. We have 4 positions like this. For the first one, here's the initial side. Second one, here is the initial side again. Third one, here is the initial side, and this is my initial side. So I'm looking for the reference angle. So for the first one, suppose my angle look like this. For the second one, suppose my angle look like this. For the third one, suppose my angle like this. For the fourth one, suppose my angle like this. So here I'm going to looking for the reference angle. So for the first one, my angle is like this. This is my angle, theta. The reference angle is an acute angle. You see the acute angle? It is acute angle, I mean like angle between 0 and 90. Formed by the terminal side, this is my terminal side, the green one, of the angle, and the x-axis. So my terminal side and the positive, and the x-axis. So this is my x-axis. And the reference angle must be, it's the acute angle between the terminal side, the green one, and the positive and the x-axis, the blue line. So this is my acute angle. I mean, this is my reference angle. We denote the reference by theta bar. Now for the second one, my second one, my angle is this. This is my angle. This is my theta. My acute angle by term is the reference angle is an acute angle between the terminal side and the x-axis. So this is the terminal side, and this is the blue one is my x-axis. So the acute angle must be from here to here. This is my reference angle. This is the reference angle. Now for the third one, here's my x-axis. First of all, this is my angle. Here is my angle. From here, like this. This is my angle. And for this, from here to here, this is my angle. Now, the reference angle for the third one is the acute angle between the green one and the x-axis. So this is my acute angle. This is the reference one. For the last one, the acute angle between the x-axis and the terminal side is this one. So now, by 1, 2, 3, 4, I can't find the reference angle. I can't find the reference angle. So I'm going to give you the table. The last things in this section, I stop after I give you the table, and next time I'm going to continue for how we can evaluate by step 1 and step 2, how we can evaluate any trigonometric function at any angle. So we finished the first one. I give you the sign. I give you the reference by giving you the table. Then next time I'm going to give you example. You should to know the angle in the first quadrant and the angle in the second quadrant and the angle in the third quadrant and the angle of the fourth quadrant, such that the first angle here, it is pi over 3. In the second quadrant, it is 2 pi over 3. In the third quadrant, it is 4 pi over 3. And here we have 5 pi over 3. All of these angles have the same reference angle. The reference angle of all of them is pi over 3. This is very important. You have to memorize it. All of them have the same reference angle. It is clear what I said here? Now for the second one, I give you another angle. So my other angle, the angle is pi over 4 in the first quadrant. In the second quadrant, it's 3 pi over 4. In the third quadrant, it is 5 pi over 4. In the third quadrant. In the fourth quadrant, it is 7 pi over 4. All of them have the same reference angle. The reference angle is pi over 4. And the last one is pi over 6. In the first quadrant, second quadrant, it is 5 pi over 6. Here in the third quadrant, it is 7 pi over 6. The fourth one, it is 11 pi over 6. All of them have the same reference angle. It is pi over 6. You should know all of them are one piece. All of these are one piece. And the same things here. So my example for next time, I'm going to do this example. Find the value for sine seven pi over 6. This is my question next time. Find the sine of 7 pi over 6. First of all, I have to know 7 pi over 6 in which quadrant? First quadrant, or in the second quadrant, or in the third, or in the fourth. Second things, you have to know what's the reference angle. 7 pi over 6 is this one. So 7 pi over 6 has a reference angle is pi over 6. So they will help me to find the value of the sine. Okay? Next time, I'm going to find the value for the sine. But please memorize all this table to help me or to help you to find the sine fast. Okay? I'll see you maybe Friday. I will post for the lecture. If we can do a lecture on Friday, I'm going to post it in the Blackboard. Okay, have a good day and good luck for in the exam.